Welcome to Chemistry Lover, and here I am with the giveaway results. First of all, I want to thank all of you who participated in this giveaway competition and sent me the answers. I checked all of your answers, and this is the list which I have. So these are the list of the names who have given the right answers for that particular question. So I will announce their names, and I also did a lucky draw, that is a random number picking, and from that I have decided who will get the prize of the giveaway, so that I will announce later. But let me first give you the answer of this question. So this is a quite straightforward question. So this was the molecule which you have to synthesize, and you have to do the retrosynthetic analysis of the molecule, and then you have to write down the forward reaction. Now most of you did the correct thing, most of you give the correct answer. Some people did little bit mistakes, silly mistakes, and some of you did really something that is not needed. So few answers seemed shocking, so I will tell that what you did mistakes in that answers. But let me first tell you that what will be the correct answer. So if I do the retrosynthetic analysis, so this is the standard retrosynthesis arrow. So this thing even some of you missed, so you must represent the arrow in the correct way. This is the standard representation of retrosynthetic arrow. So the first step would be the oxidation, that is actually this is the reduced product. So first step is the FGI, functional group interconversion, and here you will have the oxidation of two groups. Now you can write them separately or you can write them in the same step. So here you will have one double bond, and here you will have this nitro. So this is the first retrosynthetic step. So functional group interconversion occurs, this NH2 becomes NO2, and here you have a double bond. Or you can write functional group addition, this step. So actually this is not a functional group addition, so that's why I put it in the same step. Now in the next step you can see this is the standard Diels order fragmentation. So from here the fragmentation will occur, and you will have this as your substrate, and here you have NO2 pH, and this you can get again from this CC disconnection. So this is your benzaldehyde molecule, and this is the nitromethane. So these are the starting materials from where you have to start for the synthesis. Now the forward reaction would be, so this is your nitromethane. If you just use a weak sodium hydroxide solution, it will give you this nitroenolate, and then treatment of this with benzaldehyde will give you this nitroaldol product, and finally elimination of water will occur, and that will eventually give you the trans product, which is indeed needed for the reaction. So this trans product you will get because it is a thermodynamically controlled reaction, and you will get the most stable trans product. And here also you can see the trans product is needed for this reaction, because this NO2 group and this pH2 group, one is above the plane, one is below the plane. So this trans product is needed, and we will get this trans product. Now after that, if you do the Diels order reaction, thermal condition, Diels order reaction occurs in thermal condition, so that will give you this, let's say here whatever product is given I am writing, so it is NO2. And now in single step, if you use H2 PDC, you will have this reduction product pH NH2. So this H2PDC, this will reduce this double bond as well as this nitro to this NH2. Now many people used different reagents for this reduction. They used SnCl2 for the reduction of NO2, and they used H2PDC for the reduction of this double bond, but this is not needed. H2PDC do both works at the same step. Now where people did the mistake, so many people used so they directly used this one PHNH2 instead of nitro. They used this amine. So if you use this amine, what is wrong with that? So if you know the Diels-Alder reaction, or in general cycloaddition reaction, which things favors this, so you know the reaction generally occurs between the HOMO of this diene and the LUMO of this dienophile, and that's why if you can lower the energy of the LUMO, that will increase the reactivity. Now if you put this electron donating NH2 group over this dienophile, then the energy of the LUMO will rise, but if you put this NO2 group, the energy will be lowered. So that's why you have to use this and not this. So this is mistake. Now many people used this one for the reaction. There are several steps. They used this one and they did the synthesis, but you see, if you can see, so you have to break down this molecule. You cannot start from here. This is a very this is not a correct answer. You have to break down this molecule and then you have to proceed. If you just start from here, this doesn't give the correct answer. Many people even used this one, so they use this double bond. Here the problem is same. Many people did this one plus this again, or they use this acetylene. So again, this acetylene is not a good diene. You have to use this type of dienes, and this will save your steps also. This will reduce the number of steps. So these are the mistakes people did, and some of the other answers which are wrong, like people created negative charge in a position where you have nitrogen lone pair. So some people did that. This is not correct. So these are the things people did. So so this is a very trivial answer, and many books will give you this, but some people really did by their own. So I appreciate that. So some people, what they did, so they used this one, like here you can see they use this NH2PH. Some of the answers I have seen, they used this and this PHCO NH2. So then they did Br2NaOH. If you recall the Hofmann degradation, so this CO, this group will be degraded. Here your double bond. So after the degradation, you will have this NH2. Now again, it is not needed, but I think whoever did they applied their brain to do this. So I appreciate their work, because most of the books gave the answer with this nitro compound, not this one, but it will work perfectly. So you can do it, and I appreciate their answers. And some of the people did like this cyanide over here. So this is again good. So they use cyanide. So later they oxidized they hydrolyzed this cyanide to this carboxylic acid, then they made it acid chloride, then they put ammonia to produce this one, and then they did degradation. So all these things will increase your steps of the reaction. That is not good, but again, this is a retrosynthesis question, and you can do whatever you want if the steps are correct. So I appreciate these answers. So now I will announce the names who have given the correct answer. So the names are Sujan, Arnab, Shubhamoy, Akshay, Shujit, Kamal, then Ashish, Monak, then Krishna, Anjali, then Shubhadeep, then it is like Mamoni, Shayan, Mayur, and Shuman. And from all of these I performed a random number picking, which is done for the lucky draw system. So from that I got the name of Ashish as the winner. So congratulations Ashish, you are the winner of this giveaway and you will get a t-shirt from me. So this is one t-shirt with white background, another one is this one. So I will show it to you. Let me show you. So this is the t-shirt with black background, so you can see this is the t-shirt. So I'm telling to Ashish that I will send you a separate mail. So whatever your choice, whether you want a white or black t-shirt, just let me know and give me your proper address so that I can send you the giveaway prize, and also give me the body measurement, that is the size whatever you need, small, medium or large. Again I want to congratulate all of them who participated in this giveaway. In future I will do more giveaways and I will announce it earlier. So most probably I am going to do a giveaway where I can give you a book like Clayden or Carrie Sandberg. So stay tuned and thank you for watching.